Okay, let's do the analysis. For any object, for any floating object, right, such as, let's draw a simple floating object. For any floating object, there are two forces acting on the object. The first object will be the first force will be the weight of the object, right? And the second force will be the upthrust, right, due to the water displaced by the object. Right, so for a floating object, for any floating body or object, the weight of the object must be equal to the upthrust. Right? Okay? And this is, of course, nothing more than equilibrium, right? No net force. Okay, so let's call that equation 1. At the same time, we know that by Archimedes' principle, the upthrust acting on an object is given by the weight of the fluid displaced. In this case, it will be the weight of the water displaced. Okay, right, so if you combine these two principles, right, you come to the conclusion that so you look at both equation 1 and 2, you come to the conclusion that for a floating object, the weight of the object, weight of the body, is equals to the weight of the fluid displaced, weight of water in this case, water displaced by the body, by the floating body. Okay, now we have a situation in which you have a boat with an anchor on it, right? Okay, and the whole system is floating in water. Right, so from the relation we obtained earlier, right, let's call it number 3, we see that the weight of the body is equals to the weight of the water displaced. So if this anchor were to be lifted off the boat, right? So if the anchor is lifted off the boat, there will be a reduction in the weight of the system, right? So there will be a decrease in weight of the system, right? And this will be equal to a decrease in the weight of the water displaced. Okay, so this relationship follows directly from here, right? The weight of the body equals the weight of water displaced, so any change, any decrease in the weight of the body will result in a corresponding decrease in the weight of the water displaced, right? So from this, we are able to calculate the weight of the water displaced. So what is the decrease in weight? The decrease in weight is nothing more than the weight of the anchor, right? Because that is what is removed from the boat. So the weight of the anchor is equals to the decrease in weight of water displaced. So how do you find the weight of the anchor? You take the mass of the anchor times G, and that will be equal to the decrease in weight of water displaced. So how do you find the weight of water displaced? You get the volume delta V1, that is the decrease in volume, times the density of water times G. Right? So the weight of the anchor is equals to the decrease the volume of water displaced, the decrease in the volume of water displaced, multiplied by density of water, that gives you the mass of the water, decrease in the mass of water displaced times G. Right? So we can go one further step and calculate the delta V1, which is then equal to the mass of the anchor divided by the density of water. Okay, let's call that equation 4. And this is of course the decrease in the volume of water displaced by the system. We have managed to find an expression for the decrease in the volume of the water displaced as the anchor is lifted off the boat, and we call that delta V1. Right, so the anchor is now in the air. What happens if you throw this anchor into the water? Right, obviously water will now be displaced. So as the anchor goes from air into the water, what is the volume of water that is displaced? Obviously, the volume of the water displaced as the anchor goes into the water will be equal to the volume of the anchor. Right? So as the anchor enters the water, the increase in the volume of the water displaced will be equal to nothing more than the volume of the anchor. Right? And I'm going to call this increase in volume of water displaced as delta V1. Right? Therefore, delta V2. Right? So this represents the increase in the volume of the water displaced as the anchor goes into the water. Right? So how do you find the volume of the anchor? Volume is nothing more than mass of the anchor over density of the anchor, which is likely to be made of metal such as steel. Right? So let's call that equation 5. Okay, so now we take note that we have two equations. Okay, at this point in time, we have managed to obtain two expressions. The first expression represents the decrease in the volume of water displaced as the anchor is lifted off the boat and is flying through the air, right? And this will of course cause a drop in the level of the pond. The second expression, delta V2, represents the increase in the volume of the water displaced as the anchor enters the water, right? So now we compare delta V1 and delta V2, right? MA represents the mass of the anchor, which is the same in both cases, but rho W represents the density of water, and rho A represents the density of the anchor's material, which is likely to be a metal such as steel, right? So obviously the density of the anchor's material will be much greater than the density of water, right? So let's finish off the analysis here, right? Since the density of the anchor's material, right, maybe steel, is greater, in fact much greater than the density of water, right, we come to the conclusion that delta V1 is greater than delta V2. Right? This means that the decrease in the volume of the water displaced as the anchor is lifted off the boat and is flying through the air is greater than the increase in the volume of the water displaced as the anchor enters the water, right? Okay? Right, so what this means is that there will be a drop in the level of the water in the pond, right? Because now there's an overall decrease in the volume of water displaced. Right? Therefore, water level in the pond falls, right? Because of an overall decrease in volume of water displaced. Okay? Right, and that's the end of the analysis.